Greetings and welcome to Lecture 4.2, Divisions with Exponents. If you consider our last property for exponents, a to the r times a to the s equals a to the r plus s, since division is multiplication's inverse operation, we could probably expect division with the same base will result in the subtraction of exponents. For example, what if I have x to the fifth over x cubed? X to the fifth I can write out as x times x times x times x times x. X cubed I can write out as x times x times x. But x times x times x over x times x times x is just big 1. So 1 times x will be x squared. Likewise, 2 to the fourth all over 2 to the seventh, well 2 to the fourth I can write out as 2 times 2 times 2 times 2. 2 to the seventh I can write out as 2 times 2 times 2 times 2 times 2 times 2 times 2. Well, the first part, 2 times 2 times 2 times 2, all over 2 times 2 times 2 times 2, that's a big 1, right? All of the 2's end up quote-unquote canceling out, and that's a big 1. Leaving me with 1 over 2 times 2 times 2. Well, 2 times 2 times 2 is 2 cubed. So it's 1 over 2 cubed. Now that gets us ready for a definition of negative exponents. If a is a real number and a does not equal 0 and r is a positive integer, then we can say that a to the negative r will equal 1 over a to the r. Likewise, 1 over a to the negative r will equal a to the r. If you want to consider it, this line denotes when the sign changes. So if it's negative, I bring it down to the denominator, becomes positive. If it's negative in the denominator and I bring it up to the numerator, it becomes positive. So the sign changes as soon as you cross that line, in either direction. Let's take that in consideration and write each of these next expressions with the exponents as positive exponents. 2 to the negative 3, 5 to the negative 2, and 3x to the negative 6. Well, for the first one, 2 to the negative 3, I can make it positive by bringing it down into the denominator, so it's 1 over 2 cubed. And that will equal 1/8. For the second one, 5 to the negative 2. Well, 5 to the negative 2, I can bring it down into the denominator again to make it positive. So that's 1 over 5 squared. And 5 squared is 25, so it's 1 over 25. For the last one, 3 to the x to the negative 6. Now, you might ask me, why did I leave the 3 alone? Because the negative 6 is only the exponent on the x. There is not the exponent on the 3. So the 3 will stay there. I just moved the x to the negative 6 down to the denominator, leaving me with 3 times 1 over x to the 6th. Well, 3 times 1 is just 3, so it's 3x to the 6th. Let's reconsider 2 to the 4th over 2 to the 7th. Well, I can treat it like bringing the 2 to the 7th up to the numerator, which makes it negative. But then that's just 2 to the 4th minus 7, because I have multiplication in between there. 4 minus 7 is negative 3, so I have 2 to the negative 3. And to make it positive, I just bring it back down to the denominator, so I have 1 over 2 to the 3, 2 cubed. That brings us to property number 4 for exponents. If a is any real number but does not equal 0, and r and s are integers, then a to the r over a to the s is going to be a to the r minus s. Now, using our new property, let's simplify the following expressions. A is x to the 9th over x to the 6th. B, x to the 4th over x to the 10th. C is 2 to the 15th over 2 to the 20th. So x to the 9th over x to the 6th will be x 9 minus 6 and x cubed. X to the 4th over x to the 10th will be x 4 minus 10. 4 minus 10 is negative 6. I don't leave exponents negative. I have to bring it back down to the denominator for 1 over x to the 6th. 2 to the 15th and 2 to the 20th is going to be 2 to the 15th minus 20. That's 2 to the negative 5. And again, I need to bring that down to the denominator, but 2 to the 5 is 32. A next property, property number 5 for exponents, if a and b are two real numbers where b does not equal 0 and r is an integer, then we can say a over b all to the r power will result to a to the r over b to the r. Let's consider r as 3. So a over b to the r power will be a over b cubed. But a over b cubed is just a over b times a over b times a over b. But a times a times a is a cubed, and b times b times b is b cubed. So you see that that property does hold true, and it's going to hold true for any integer that r equals. If you're interested in the proof of this, you can run through and see each line of this proof. Just pause the video. The reason for each step is to the right, so go ahead and run through that if you choose. Let's run through some examples using our property number 5. X over 2 all to the 3rd power, 5 over y all to the 2nd power, 2 over 3 to the 4th power. So x over 2 cubed is going to be x cubed, 2 cubed. X cubed we just leave alone, but 2 cubed is 8. 5 over y all squared. We distribute the 2, the 2nd power, to both the numerator and the denominator, leaving me with 5 squared over y squared. 5 squared is 25 over y squared. Now I'm going to leave that last one for you to do for your class problem. So I want you to bring me back what the answer is to 2 over 3 to the 4th power. Now there's two special exponents that we haven't really chatted about yet, but let's look at them. We're going to talk about the exponent of 0 and the exponent of 1. Let's consider x cubed over x squared. Well, if I work that out the long way, x cubed is x times x times x, x squared is x times x. Well, the x over x and the x over x are just 1, so that leaves, pardon me, x. If we use our property, x cubed over x squared is going to be x 3 minus 2. Well, 3 minus 2 is 1. So we know x to the 1st power equals x. Now let's consider 5 squared over 5 squared. And we'll do it both ways, the long way and our new short way. 5 squared over 5 squared is just 25 over 25, which is 1. 5 squared over 5 squared will be 5, 2 minus 2, and 2 minus 2 is 0. So 5 to the 0th power is 1. And in fact, we now have x to the 1st equals x. In other words, there is an implied 1 power there. And x to the 0th power is 1, because we can play this game with any number except 0. As long as x does not equal 0, this property holds true. This definition holds true. Here's some examples we can work with. 8 to the 0th power, 8 to the 1st power, 4 to the 0th power plus 4 to the 1st power, and 2x squared y all to the 0th power. Let's take the first one. 8 to the 0th power is 1. Here's our definition. Any number, as long as it's not 0, to the 0th power is 1. So 8 to the 0th power is 1. 8 to the first power is 8. Well, our rule is any number to the first power is itself. So 8 to the first power is 8. 4 to the 0 plus 4 to the 1. Well, 4 to the 0 is 1, and 4 to the 1 is 4, so 1 plus 4 is 5. And the last one, 2x squared y to the 0th power. Well, that's going to be 2 to the 0, x squared to the 0, y squared to the 0, which is really 1, x to the 0, y to the 0, which is 1 times 1 times 1, which is 1. Anything to the 0 power, as long as it's not 0, is 1. Here's a nice handy list of definitions and properties that we've gone through. So take a look at this, jot down some notes if you need to. It's nice and handy to have all of these properties and definitions in one location. Let's run through a couple of examples that use a multiple or a multitude of our properties that we've now learned. So we have 5x cubed all raised to the 2nd power all over x to the 4th. So I'm going to distribute the 2 both to the 5 and the x cubed. So 5 squared x cubed squared all over x to the 4th. But I can do the x cubed to the square power. That's just going to be 3 times 2. 5 squared x 6 all over x to the 4th. 5 squared is just 25, x to the 6th, x to the 4th. Using our 4th property, I can now say 25 x to the 6th times x to the negative 4. But that's 25 x to the 6th minus 4, leaving me with 25x squared. That's my final solution to that one. Let's try another one. X to the negative 8 all over x squared cubed. Well, let's see what I can do first. I can do the x squared cubed. That's going to be x to the negative 8 all over x to the 6th. Now using my 4th property again, it is now going to be x to the negative 8 minus 6 will be x to the negative 14. But I don't want a negative exponent, so I need to bring it back down to the denominator to make it a positive exponent. So my final answer to that one is 1 over x to the 14th. All right, one more. There's a couple of ways we can do this one. So I might show you both ways, so hold on. Let's go with y. Let's distribute the 2 to both of them. So my first way of doing it is going to be y to the 10th over y to the 6th. Now I can use another property to say y to the 10th minus 6, and that's y to the 4th. That's one way of doing it. The other way of doing it is to do the parentheses first, which would be y to the 5 minus 3 squared, which is y squared squared, but that's y to the 4th. Either way, I do get the correct answer, y to the 4th. I've worked out a few more problems for you. Go ahead and follow along for each step. Pause the video if you need to. This is the end of part 1 to this video, so until next time, be seeing you.